Hello everyone, this is Sir Hale Consuelo Jr. Welcome to another Math 21 with Sir G. Another great and lesson to be discussed. Without further ado, join me. So our today's topic is all about the union of two events. So according to this, if E and F are events, what is the probability that E or F occurs? So that is the question, no? The word "or" indicates that we want the probability of the union of these events. So that is E union F. Huh? So we need to find the number of elements in E union F. So if we simply added the number of elements in E to the number of elements in F, then we would be counting the elements in the overlap twice. So once in E and once in F. So to get the correct total, we must subtract the elements in the intersection between set E and set F. So the formula for the union of two events, E and F in this case, is equal to the probability of E plus the probability of F minus the probability of the intersection between set E and set F. So let us have an example. So what is the probability that a card drawn from a standard deck card is either a base card or a spade? So the first thing that we have to do is to let E be our base card and we let F be our card of spade. Then we're going to analyze based on the standard deck of cards how many base cards do we have. So we have 12 cards who has a base card. Of course, the base cards are king, queen, and jack. So we have 4 kings, 4 queen, and 4 jacks. And of course, the probability that a card is a spade, so it has 13 cards all in all, because in a standard deck of cards we have 4 suits, so each suit has 13 cards. So the following suits are the heart of card with a heart, a spade, sorry for the drawing, a club or a clubber, and the diamond. So these are 4 suits with 13 cards each. Okay. Alright, so we know that the total number of standard deck of cards is 52. So again, using the probability formula, so the probability of a certain event is equal to the number of elements what we wanted, alright, and what we have. Okay, so what we have is 52 cards all in all. Okay, and what we wanted is an event where a base card is drawn, so 12 out of 52. And for the second event, which are card of spade, so there are 13 cards of spade out of 52 cards. So that is the probability of E, where an event will, or a card is drawn with a face card on, and the probability of F, where a card is a spade, so 13 over 52. And of course, based on our formula, we have to get the probability wherein the intersection of these two events may happen, no? So there are king, queen, jack, who is spade, so that is the intersection between the two. Okay, this is both a face card and a spade card, no? So king, queen, and a jack, so that is 3 out of 52. Now using our formula for the union of two events. So the probability of the union of two events is equal to the probability of the first event plus the probability of the second event minus the probability of the intersection between the two events. Then getting the given, so the probability of E is 12 over 52, the probability of F is 13 over 52, and the probability of the intersection between these two events is 3 over 52. Then let's simplify. So 12 plus 13, that is 25, minus 3, so that would be 22 all over 52, or simply 11 over 26, or 0.4230769, or simply 42.3%. So therefore, the probability that a card drawn at random from the standard card deck is either a face card or a spade is 42.3%. So that's it. Alright, so I hope you got it, guys. So let's proceed on our next item. So let's talk about the intersection of two events. So here, guys, the probability of two events joined by the word and. So kanina or, this time we use the term or the word and. So in other words, the intersection of two events. So using this word and, meaning we are looking for the intersection of two events. So when the occurrence of one event does not affect the probability of another event. So we say that the events are independent. So for instance, if a balanced coin is tossed, the probability of showing heads on the second toss is 1/2 regardless of the outcome of the first toss. So any two tosses of a coin are independent. So if E and F are independent events in a sample space S, then the probability of E and F is this one. So the probability of E intersection F is equal to the probability of E times the probability of F or set F. So let us have an exercise. So in here, guys, a jar contains 5 red balls and 4 black balls. So in here, so a ball is drawn at a random from the jar and then replaced. Then another ball is picked. So what is the probability that both balls are red? So the events are independent, no? So the probability that the first ball is red is 5 over 9. Then we return the ball, no? Then the probability of the second ball to be red is also 5 over 9, since we replace or we return the ball that we've got, no? So thus the probability that both balls are red is 5 over 9 times 5 over 9, or simply 25 over 81, or 0.31, or 31%. So the probability that both balls are red is 31%. Alright. Okay, so let's proceed on the next one. So this time we are going to talk about the union of mutually exclusive events. So two events that have no outcome in common are said to be mutually exclusive. For example, in drawing a card from a deck of a standard deck, no? The events that the card is an ace and the card is a queen are mutually exclusive, because a card cannot be both an ace and a queen at the same time. So if a certain event E and F are mutually exclusive events, then the intersection between E and F contains no element. Take note, the intersection between these two events has no element. So thus the intersection, or the probability of the intersection between these two events is equal to 0. So therefore, the probability of E union F is equal to the probability of E plus the probability of F, because the probability of the intersection between these two events is 0. No? So we're going to use this one. Alright, so let's have an exercise. So a card is drawn at a random from a standard deck of cards. So what is the probability that a card is a 7 and a base card? So there are 4, 7, and there are 12 base cards. So the probability is simply 4 over 52, and this is 12 over 52. Simply getting the sum, we have 16 over 52, or simply 4 over 13, and that is 30.77%. So therefore, the probability that a card is either a 7 and a base card is 30.77%. Alright guys, so at this moment, so I guess you are ready. So it's your turn to solve some problems. So here are the first 3 problems that you are going to solve. So what is the probability that a card drawn at random from a standard 52 card deck, either an ace or a diamond? When I say 52 card standard deck, so it has no joker, no? So for number 2, a jar contains 6 green balls, 5 red balls, and 9 yellow balls. So a ball is drawn at a random from the jar and then replaced. Then another ball is picked and then replaced. So what is the probability that each balls are green? And for number 3, a card is drawn at a random from a standard deck of 52 cards. So what is the probability that the card is either a 5, an ace, and a base card? Alright. Okay, so I will give you 20 minutes to finish this, guys. So please pause the video, then play it again after 20 minutes. Alright. So let's discuss the solution for the first problem. So what is the probability that a card drawn at random from a 52 card deck is either an ace or a diamond, no? So there are 4 aces out of 52, of course. So there are 13 diamonds, so each suit has 13 cards, so 13 over 52. Then the intersection between these two events, so there are 1 diamond, which is an A, so therefore that is 1 over 52. Then we simply use the pattern or the union of 2 events, so that is equal to the sum between the 2 events minus the intersection between the 2 events. So therefore, plugging in the values of the probabilities, then we will arrive at 4 over 52 plus 13 over 52 minus 1 over 52, which is the intersection between these 2 events. Then simplifying, we will arrive at 16 over 52. Getting the lowest term, we have 4 over 13. And using our calculator, so we will arrive at 0.307692, or simply 30.77%. So therefore, the probability that a card drawn at random from standard card deck is, which is either an ace or a diamond, is 30.77%. Alright, so let's proceed on the second one. So a jar contains 6 green balls, 5 red balls, and 9 yellow balls. So a ball is drawn at random from the jar, then replaced. Then another ball is picked and then replaced. So what is the probability that each balls are green? So take note guys that these events are independent. So the probability that the first ball is green, which is 6 over 20, no? Then the probability of the second event is also 6 over 20, no? And then the probability of the third ball is green is also 6 over 20. So thus the probability of each balls are greens are as follows. So 6 over 20 times 6 over 20 times 6 over 20, getting the lowest term. So that is 3 over 10 times 3 over 10 times 3 over 10, or simply 27 over 1000, or simply 0.027 or 2.7%. So therefore, the probability that each balls are green, containing a jar with 6 green balls, 5 red balls, and 9 yellow balls, is 2.7%. And finally, the last exercise, a card is drawn at random from a standard deck of 52 cards. So what is the probability that the card is 5, an ace, and a base card, no? So please take note guys that these events are mutually exclusive, since a card cannot be a 5, alright, cannot be a 5, an ace, and a base card at the same time. So we want the probability of E or F or G. In other words, the probability of E union F union G. So we simply get the probability of each sets, then getting the sum. So of course there are 4 5 cards out of 52. So there are 4 ace cards out of 52, and there are 12 base cards out of 52. So getting the sum, so we will arrive at 20 over 52. Then getting the lowest term, we have 5 over 13, and pressing your calculator, we will arrive at 0.384615, or simply 38.46%. So therefore, the probability that a card is either a 5, an ace, and a base card drawn random from the standard deck of 52 cards is 38.46%. Alright, I hope these are clear. So if there are some confusions or questions, you may always pause the video, then rewind, rewatch, then try to use your pen and paper, solve the problem as many as you needed to. Alright? Okay, so until our next Math 21, this is Sir G. Goodbye everyone. Thank you.